Hello everyone. Today we will study about the esterification reaction, that is the formation of ester. In this reaction, the alcohols and phenols, that is the organic compounds containing hydroxyl groups, when combined with acid, when combined with carboxylic acids or the derivatives of carboxylic acid like acid anhydrides and acid halides, in the presence of concentrated acid, they always yield ester. I repeat, the organic compounds containing hydroxyl groups like alcohols and phenols, when combined with carboxylic acids or the derivatives of carboxylic acid, in the presence of concentrated acids, they always yield ester. For example, in the given reaction, Ar is represented as aryl group and R represent an alkyl group and R dash is also an alkyl group. In order to differentiate between the alkyl groups of two different compounds, we use R dash. So, in the reaction, the hydrogen of alcohols or phenols and the hydroxyl groups of acids combine to form water, and the remaining part, that is RO and RCO, combine to form the ester. Similarly, in the second reaction, the hydrogen of alcohols or phenol and the RCO groups of acid anhydride. Acid anhydride is formed by the removal of water from 2 moles of carboxylic acid. So RCO, the whole twice O, is represented in this manner. So the RCO oxygen, when combined with alcohols, they will release RCO groups and the hydrogen of alcohol to form acid. That is the hydrogen of alcohol and RCO and O of acid anhydrides combine to form an acid, and the remaining parts will form an ester. In the third reaction, the hydrogen of alcohols and the chlorine of acid chlorides combine to form hydrogen chloride, and the remaining parts combine to form ester. So these are the reactions in which the formation of ester takes place. Therefore, these reactions are called as esterification reaction. The major point to be remembered in this reaction is that the first two reaction is carried out in the presence of acid, and both the reactions are reversible in nature. The third reaction is carried out in the presence of base, and this reaction is irreversible in nature. I repeat, the first two reactions are carried out in the presence of an acid, and both the reactions are reversible in nature. And the third reaction is carried out in the presence of base, and the reaction is irreversible in nature. The first two reactions are reversible in nature, and in order to bring out the maximum yield of ester, we need a dehydrating agent which can continuously remove the water from the reaction. That dehydrating agent is the concentrated sulfuric acid. So, concentrated sulfuric acid will continuously remove the water and it will yield the maximum amount of ester. The second point to be remembered in this reaction is that the third reaction, the last reaction, was carried out in the presence of base, which is used to neutralize the acid formed as a byproduct in that reaction, so that we can get the ester easily. One more thing, that a reaction is called as acetylation reaction when An atom or groups of atom is replaced by CH3CO group. I repeat, acetylation reaction is the reaction in which a group of atoms or an atom is replaced by CH3CO group. For example, the acetylation of salicylic acid. Salicylic acid means when a benzene ring contains hydroxyl groups and carboxylic groups adjacent to each other, so that is an salicylic acid. That will be easy to learn. Benzene ring and one hydroxyl group and carboxylic group to its neighbor. When it combines with acid anhydride, that is acidic anhydride, CH3 COOH is an acid. Again, I repeat, CH3 COOH is an acetic acid, and if 2 moles of acetic acid removes 1 mole of water, so 1 mole of water, so it will form CH3CO, and the oxygen, that is acetic anhydride. Acetic anhydride will be CH3CO and CH3CO and O. This will be acetic anhydride. So the hydroxyl group of salicylic acid will remove the hydrogen, and the acetic anhydride will remove CH3CO. CH3CO is the acetic anhydride. When the hydrogen of alcohol and CH3CO and O combine, so they will form acetic acid, and the remaining part will get added here. The remaining part will be CH3CO, that is the acetyl group. So hydrogen will be replaced by CH3CO group. So this reaction is the acetylation reaction.